Introducing the derivative. Use the definition to find the slope of the line tangent to the graph of f of x at P. Then determine an equation of the line. First, we recognize that a is equal to -1, so in the formula we replace a with -1. Next, we look at f of x. Now what does f of x do to what it sees? Whatever it sees ends up in the denominator. So if it sees x, then f of x is 1 over x. If it sees -1 plus h, then f of -1 plus h is 1 over -1 plus h. So when we go to rewrite the formula using f of x, this is what we get. We need to find the limit. In order to find the limit, we first simplify the expression inside. Now there are two reasons for that. One is just it's so ugly inside that limit expression. Second of all, at this point we cannot do a direct substitution because we would end up with 0 over 0. So we're hoping by simplifying the expression that we'll end up with something where we can do a direct evaluation. So let's just simplify the expression, see what we have, and go from there. So the first thing I would do is recognize that if you have an expression divided by h, that's the same as the expression times 1 over h. That's how I deal with a complex fraction. It's much easier to write it this way. Okay, so the next thing I'm going to do is just clean it up a little bit. I've got -1 over a -1. That's the same as +1. Next, I need to find a common denominator for the expression inside of the parentheses there on the right-hand side. And so in order to do that, I need to rewrite 1. So 1 is just going to be -1 plus h over -1 plus h. Now that I have a common denominator, I can just add those numerators. And so I get h over that common denominator of -1 plus h. And you can see the h's cancel, and I'm left with 1 over -1 plus h. Now, that is much simpler than what we started with. Now that it's simpler, we ask, is it possible to take the limit? So let's look at the limit. Is it possible now to do find the limit with a direct substitution, or do I run into trouble? Well, if h is going to 0, the denominator is just going to -1. That causes no problems at all. So we can do a direct substitution, and we get -1. So we now know that the slope of the line tangent to the graph is -1. What's the equation of the line tangent to the graph? To do that, I use the point slope formula for the equation of a line. I use the fact that y naught is -1 and x naught is -1, and the slope I just found to be -1. So in order to get the equation in slope-intercept form, all I'm going to do is solve for y. There's a lot of negatives here, so part of the cleanup is just dealing with the negatives. And once I solve for y, I get y equals -x minus 2, which is the equation of the line tangent to the graph of f of x at the point -1, -1. And I went to Wolfram Alpha and asked them to graph it for me, and you can see the line y equals -x minus 2, how it's tangent to the graph of 1 over x at the point -1, -1. You take care and have a great day.